Okay, so this is number 1, and only a portion of this is what I'm going to work that could be on the 2021 exam, but maybe more in the future. The equivalence point that's referred to in letter A is where the moles of acid are equal to the moles of base when two things are titrated together. And if the moles of acid are equal to the moles of the base, and both of them are volume and molarity, if you know the molarity triangle is equal to molarity equals moles divided by liters, then moles are equal to molarity times liters. And so what you could write is that the molarity of the acid times the volume of the acid is equal to the molarity base times the volume of the base, especially if it's a 1-to-1 ratio, which NaOH is with acetic acid right here. And so acetic acid, of course, is HC2H3O2, one acidic hydrogen, plus NaOH, one OH right here, and so then we're going to get water, and we're going to get the salt NaC2H3O2. Oops, 2 right there. So it's a 1-to-1 ratio, so 1 mole equals 1 mole of acid to base. Alright, so anyway, the moles of acid are equal to the molarity of the acid, which is 0.5 molar, times the volume of the acid, which is 10 milliliters, but I need to put it in liters, so that would be 0.101, and that would be in liters, and that it would equal to the molarity of the base, which is 1 molar, times the volume of the base right here. So how much base is required to reach that? We divide both sides by 1, and 0.5 times 0.01 is equal to 0.005, which is 5 milliliters. And then in letter B, it says calculate the pH of the acid before the titration is begun. So the acid is a weak acid, HC2H3O2, and before the reaction happens, of course, the acid is dissolved in water, and so when in doubt, react it with water. We'll get some H3O+, which is the thing we want to know, because then we can find the pH, and then some C2H3O2- ion. Initial change end. Initially, we're given 0.5 molar of this weak acid. This doesn't matter because it's a pure liquid, and there's none of this to start with and none of this to start with before the reaction proceeds. We'll lose X amount of this and gain X over here and gain X over here, so we have 0.5 minus X here, X and X here. Products divided by reactants, ignoring the X because it's small in comparison to the 0.5, is equal to the Ka. And the Ka is 1.8 times 10 to the negative 5th, which is given to me in the problem right here. Solve this for X. X ends up being 0.003 molar. And then I want to know the pH, so the negative log of the 0.003, because this is the H3O+ ion concentration right here, and that equals 2.52 for the pH. Alright, that's number 1. Number 2. Each of the following reactions is an acid-base reaction. Write and identify the conjugate acid and the conjugate base. Make sure to fill in the blanks and to include charges if appropriate. So first we have weak acid with weak base right here. The acid will donate one of its protons, and therefore the conjugate acid would be NH4+1. So it's what is created after the base accepts its proton. And then HSO3- would be what's left over after the acid releases its proton. So that's the conjugate base. Down here you have to identify which is the acid and which is the base, and you can see that the carbon-containing compound gains 1 hydrogen going over here, which means this is a base because it accepts a hydrogen, and this is an acid because it releases a proton or gives up a proton and becomes OH-. Right here you can see H2ASO4 becomes H3ASO4, so the arsenic containing species right here gets 1 more hydrogen. Things that get hydrogens are called bases, so this is the base. And this one you can see loses a hydrogen because it becomes C2H3O2- right here, so this is called the acid. This is what remains after the acid releases its proton, so this is called the conjugate base. and this is what is created after the base accepts its protons. This is called the conjugate acid. And then letter D, HCl releases a proton, so then what would happen after that is we'd get Cl minus, and this is called the conjugate base, and NO2 minus would get a hydrogen, so that becomes HNO2. This is called the conjugate acid.